Welcome to the podcast on evaluating functions. Evaluating functions means given x, find y. Y, remember, means f of x in function notation. Now, since f of x is equal to y, then an ordered pair xy is actually an ordered pair xf of x. The y and the f of x mean the same thing. So let's take a look at this function f that I have drawn here. In the first ordered pair, x is 4 and y, or f of x, is 2. So what we could say is that this ordered pair 4, 2 is the same as the ordered pair 4, f of 4, where f of 4 is 2. The ordered pair negative 6, 3 is the ordered pair negative 6, f of negative 6, where f of negative 6 is negative 3, etc. Below, I have a function g, a second function, and for example, if you look at the second ordered pair, where x is negative 6, y is negative 4, so we would say when x is negative 6, g of negative 6 is negative 4. So that's the same as the pair x, or negative 6, g of negative 6. So g of negative 6 is negative 4. And let's take a look at a sample problem, how we might evaluate an expression using these function definitions in their ordered pair forms. The first one says find f of negative 6 minus 2g of 5. Now f of negative 6 is a y, g of 5 is a y. We have to figure out what they are. So what I'm going to do is I'm going to write an empty hole for f of negative 6. The 2 here means 2 times, and then I'm going to write an empty hole for g of 5. And let's see, what do we get for f of negative 6? Well, our notation is f of x. So if we're looking for f of negative 6, we're saying that x is negative 6. So I go up here to f. I look for x is negative 6. That's in the second ordered pair. What is f of negative 6? Well, f of negative 6 is negative 3. So this is just a negative 3. I go into the second empty hole. I'm looking for g of 5. I go to the function g. This is telling me that the x is 5. So I'm looking for an ordered pair where x is 5. Well, that would be the first ordered pair. So g of x, or g of 5, which is the second element, is the y. So that's telling me g of 5 is 7. So I'll put 7 here for g of 5. So my problem is just negative 3 minus 2 times 7. That's negative 3 minus 14, which is negative 17. And that is how you evaluate using the ordered pair form of a function. I list as my second form something called a chart form, which I did not list in the first video because the chart form is really just the ordered pair form of a function put into the form of a chart. So the first thing I'd want to know is, well, what are all my x's for f and g? Well, for f, I get 4, negative 6, 2, and 0 for my x's. G gives me 5 for an x. Negative 6 we already had. 2 we already had. 0 we already had. And it also gives me negative 1 for an x. So these are all the x's for f and g. Now, what I list in the rest of the chart is just f of x and g of x. So what is the y that corresponds to x equals 4 in the function f? So I go up here. Here's x equals 4. My y is 2, so I put a 2 here. What is the g that corresponds to x equals 4 in the function g? Well, I scan my function g looking for x equals 4, and I don't find it. So g of 4 is not defined, so I put here undefined. I go to negative 6 for x. Well, what is the f value corresponding to x is negative 6? Well, that would be here in the second ordered pair, so I put negative 3. Well, what is the g corresponding to negative 6? That would be also in the second ordered pair. G of x, or g of negative 6, is negative 4. I go to the 2. In f, the 2 corresponds to the y equal 1, so f of 2 is equal to 1. For g, 2 corresponds to 4, so for g of 2, I put 4. For 0, f of 0 is 0. For 0, g of 0 is 2. For 5, x is never 5 in f. It's 4, it's negative 6, 2 and 0, but it's negative 5, never 5. So this is going to be undefined. There is no x equals 5 in f of x. But there is in g of x. In g of x, when x is 5, g of 5 is 7. So I put here 7 for g of 5. In also g, corresponding to negative 1, I get this last ordered pair. When x is negative 1, g of negative 1 is 1. So for g of negative 1, I put 1. But again, there is no negative 1 value for x in f. As I scan through all the x values of f, I see no negative 1, so that again is undefined. Now that I've made up my chart from the ordered pairs, I'm ready to answer questions. The first question says find negative 2f of 4 minus 3 g of 0. So I put negative 2, empty hole, minus 3, empty hole. Not a very good empty hole. It looks like a 7. Empty hole. So in my first empty hole, what I want is f of 4. Now the notation, remember, is f of x. So if I'm looking for f of 4, that's telling me x is 4. So I go over here to f, or to my chart. I look for x is 4. I see what f is. F of 4 is 2. So right here I put a 2. I now need g of 0. So again, I go to my chart. I find x equals 0. F of 0 is 0, but I don't want f of 0. I want g of 0. So g of 0 over here is 2. So I put in a 2. So I get negative 4 minus 6, which is negative 10. My second problem says find negative g of 4. Well, in order to find negative g of 4, I need to first find g of 4. So I go look at x equals 4. So I come over here and I look over at its value for g, and it says undefined. There is no such thing as g of 4. So this is undefined. And remember, chart form is no different than ordered pair form. It's just that your ordered pairs are put in the form of a chart instead of listing a bunch of separate ordered pairs. It just saves a little time and space to do it in chart form. The most common form for evaluating functions is the formula form. Here in the first one I have y, or f of x, is 3x minus 5. In the second one, my y, but this time a different y, a g of x, is x squared minus x, and I'm asked to find negative 2 f of 4 plus 3 g of negative 2. Now f of 4 is the y value that corresponds to x equals 4 in the function f. Now I don't know what that is, so I'm just going to put minus 2 empty hole, and then I'll go figure out what f of 4 is, and then I'll put plus 3 empty hole and figure out what g of negative 2 is. Now if I want to know f of 4, or f of anything for that matter, I write f with empty holes. That looks like this. F of empty hole equals 3 empty hole minus 5. And if what I'm looking for is f of 4, I put 4's in my empty holes. And now I just evaluate. 3 times 4 is 12, minus 5 is 7, so 7 goes in the first empty hole. Now, if I want to evaluate g, I do it the same way. I simply write g with empty holes. G of empty hole is empty hole squared minus empty hole. And I'm looking for g of negative 2 right here. So I want negative 2 in the empty holes. So I get negative 2 squared, which is 4. Minus negative 2 is the same as plus positive 2, so that's plus 2, which is 6. So 6 goes into the empty hole that I left for g of negative 2. Now I'm ready to evaluate. I have negative 14 plus 18, which is 4. And then the last way to evaluate functions is from their graphical form. Here I've done a graph of f of x, so you can see that, for example, f of negative 3 is positive 3. That is, when x is negative 3, f of x, or y, this is the y-axis up here, is positive 3. When I'm 3 to the left, I'm 3 up. F of positive 3 is negative 4. F of positive 3 is negative 4. And this is because the point 3, negative 4, 3 to the right, 4 down, is on the graph. So 3 is the x, negative 4 is the y. Here we're asked to evaluate negative f of negative 3. Well, it's going to take us some doing to find f of negative 3, so I'll just write negative empty hole. Minus 2 times f of 0, I'll just say minus 2 times empty hole. Plus 3 f of 7, I'll just say plus 3 times empty hole. So let's first go and figure out what do we get for f of negative 3. Well, that's telling me that negative 3 is the x. So I go over here, 1, 2, x is negative 3. What y corresponds to that? Well, here's the point on the graph. The y that corresponds to that is 3, so f of negative 3 is 3. I come to look at f of 0. Well, here's x equals 0. My y for that value is right down here at negative 1, so f of 0 is negative 1. I go to look for f of 7. That's telling me x is 7. So I go way out here to the end, x is 7, and I see that y is 1. Y is the same as f of 7, so I put 1 in for f of 7. And now I'm ready to evaluate. Negative 3 plus 2 plus 3 gives me 2. And we have learned how to evaluate functions, whether they're in the ordered pair form, the chart form, the formula form, or the graphical form. And that completes this podcast.